On Windows, you have C:\/ and D:\/ drive letters that represent physical storage devices. Linux takes a completely different approach. There is one root, written as a /, and every single file on the system, whether it's on a hard drive, a USB stick, a network share, or even virtual kernel memory, appears somewhere under that single root. This is called the Filesystem Hierarchy Standard, or FHS. It's not just how Linux organizes files, it's a standard that defines where everything should live, so that any software written on any Linux distribution can predict where to find configuration files, log files, executables, and libraries. When you run ls/, you'll see a list of directories, each one with a specific, well-defined purpose. /etc is for configuration. /var is for variable data that changes at runtime. /home is for user files. /usr is for user-installed programs. /proc is a virtual window into the kernel. None of these are arbitrary, each exists for a reason. Understanding this hierarchy means you always know where to look. Jinx config? /etc/jinx. Application logs? /var/log. Your app files? /home/ubuntu or /opt. This chapter is your map. If you want to know how a program is configured on a Linux system, you look in /etc. That's the convention. Always. The name /etc originally stood for etc. It was literally the catch-all for everything that didn't fit elsewhere in early Unix systems. Over time, it evolved into the definitive location for system-wide configuration files. Every major service has its own subdirectory under /etc. Jinx lives in /etc/jinx. SSH configuration is in /etc/ssh/sshd_config. DNS resolver settings are in /etc/resolve.conf. Hostname is in /etc/hostname. System users and their hashed passwords live in /etc/password and /etc/shadow. Here's what makes /etc important for your work. When you install Jinx and need to configure it, you go to /etc/jinx/sites available/ and create a file there. When you need to configure how your server resolves domain names, you edit /etc/resolve.conf. When something is broken with a service, the first place to look is its configuration directory under /etc. One critical rule: files in /etc are system-wide and almost always require root to edit. Sudo nano /etc/jinx/jinx.conf is the normal workflow. The files here affect the entire machine, be deliberate. The name /var stands for variable, and that tells you exactly what lives here. Data that the system generates and modifies while it's running. The most important subdirectory for day-to-day server work is /var/log. This is where every service writes its logs. Jinx writes access and error logs to /var/log/jinx/. System logs go to /var/log/syslog or /var/log/messages depending on your distribution. Authentication events, including SSH logins, go to /var/log/auth.log. When something breaks on your server, /var/log is your first destination. tailf /var/log/jinx/error.log shows you Jinx errors in real time. grep error /var/log/syslog tail-50 shows you the last 50 system errors. Other important things in /var/var/lib holds persistent application data, databases, package manager state. /var/cache holds cache data that can be regenerated. /var/run holds PID files, small files containing the process ID of running services, so init systems know what's running. One operational concern: /var/log can grow without bound if you're not careful. On production servers, log rotation, the automatic compression and deletion of old log files, is configured with log rotate. This keeps /var/log from filling your disk and causing mysterious failures. Every user on a Linux system gets a home directory, a private space where their personal files, configurations, and projects live. For regular users, home directories are under /home. The user Alice gets /home/Alice. The user Ubuntu, which is the default user on Ubuntu servers, gets /home/Ubuntu. The tilde shortcut always refers to the current user's home directory. When you're logged in as Ubuntu, cd takes you to /home/Ubuntu. When you're logged in as Alice, cd takes you to /home/Alice. Home directories contain .files and directories whose names start with a dot, which are hidden by default from ls. These are almost always configuration files for user-level tools. .bashrc and .bash_profile contain your shell configuration aliases, environment variables, path modifications. .ssh contains your SSH keys and authorized _keys file. .gitconfig contains your Git identity. The root user, the super user, is special. Root's home directory is not under /home. It's slash root at the file system root level because root is separate from all other users by design. For your Node.js app, a common pattern is to put it in slash home slash ubuntu slash myapp using the home directory as a convenient workspace. Alternatively, some admins prefer slash opt or slash srv for application code. The convention matters less than consistency. Slash proc is one of the most fascinating parts of Linux because it's not a real directory. It doesn't store files on disk. It's a virtual file system that the kernel creates in memory, exposing live information about the system in a file-like interface. Every running process has a directory under slash proc named with its PID, its process ID. If Jinx is running with PID 1234, there's a directory slash proc slash 1234 slash that contains everything you could want to know about that process, the command that started it, its environment variables, the files it has open, its memory maps, its resource usage. Some of the most useful things in slash proc slash meminfo shows current memory usage. Slash proc slash gwinfo shows CPU information. Slash proc slash net slash TCP shows all active TCP connections. Slash proc slash uptime shows how long the system has been running. Why does this matter? Because when you run tools like PS, Top, or Netstat, they're reading from slash proc to get their data. You can go directly to slash proc yourself. Cat slash proc slash meminfo gives you raw memory statistics. Cat slash proc slash 1234 slash commline shows you exactly what command started process 1234. The everything is a file philosophy in action. The kernel exposes its internal state as files you can read with ordinary tools like cat and grep. No special APIs needed. When you install a program, where does it go? Usually somewhere under slash usr, the Unix System Resources directory. This is where the vast majority of user-facing programs and libraries live on a modern Linux system. Slash usr slash bin contains most of the programs you use: ls, cat, grep, curl, git, python 3. These are the standard user utilities. Slash usr slash local slash bin is for programs you install yourself, outside of the package manager, node.js, custom scripts. By convention, the package manager owns slash usr slash bin, and you own slash usr slash local slash bin. Slash usr slash lib and slash usr slash local slash lib contain shared libraries, the .so files that multiple programs share to avoid duplicating code. When node.js says it can't find a library, it usually means something in slash usr slash lib is missing. Slash bin and slash spin are legacy locations that on modern systems, Ubuntu 20+, are actually symlinks to slash usr slash bin and slash usr slash spin. So lsla slash bin shows slash bin dash usr slash bin. The distinction was historical. Slash bin was on the root file system for early boot, before slash usr was mounted. Slash spin and slash usr slash spin contain system administration binaries, programs typically run by root. Iptables, Jinx, systemtl, fdisk, they live here. The important takeaway: when a command isn't found, check whether its directory is in your path. The path environment variable is the list of directories the shell searches for commands. Two more directories worth knowing. Slash tmp and slash op serve very different purposes but are both useful to understand. Slash tmp is the temporary directory. Any program can create files here without needing special permissions. The key characteristic of slash tmp is that it's cleared on reboot. Nothing in slash tmp is persistent. Programs use it for build artifacts, download staging, inter-process communication via socket files. On servers with a lot of activity, slash tmp can fill up. One debugging tip: if a program is failing mysteriously and has no obvious error, check whether slash tmp is full with dfh slash tmp. A full slash tmp causes strange failures because programs can't create temporary files. Slash op stands for optional software. It's the conventional location for self-contained third-party application packages, software that doesn't fit neatly into the standard package manager hierarchy. Commercial software, bundled applications, or applications that ship their own dependencies often install into slash opt. If you have a self-contained application suite, slash opt slash myapp is a perfectly valid location. Some teams also use slash srv for service data, webroot files, FTP data. You'll see slash srv slash www or slash srv slash app in some configurations. It's less commonly used than slash opt or slash home, but it exists in the standard. Knowing all these directories means when you see a path in an error message or a config file, you can immediately understand what kind of resource is being referenced. On modern Ubuntu servers, services, long-running programs like Jinx, PM2, PostgreSQL are managed by systemd. And systemd's configuration lives under slash etc slash systemd. A service is just a unit file, a text file that tells systemd how to start, stop, and monitor a process. The pm2 startup command generates a unit file in /etc/systemd/system/pm2 ubuntu.service. When you install Nginx via apt, it creates /lib/systemd/system/nginx.service. The systemd command is your interface to systemd. Systemd status Nginx shows whether Nginx is running, its last few log lines, and its PID. Systemd start Nginx starts it. Systemd stop Nginx stops it. Systemd restart Nginx stops and starts it. Note this causes a brief downtime. Systemd reload Nginx sends a signal to reload configuration without restarting, 0 downtime. Systemd enable Nginx makes Nginx start automatically on boot. It creates a symlink in the appropriate systemd target directory. Systemd disable removes that symlink. This is the operational layer that holds everything together. Your app dies? Systemd with pm2 restarts it. Server reboots? Systemd starts Nginx and pm2 automatically. Understanding systemd is understanding how Linux keeps services alive. 2 essential commands for navigating the file system in production: find and df/do. Find is how you locate files anywhere in the file system. Find /etc name nginx.conf searches for a file named nginx.conf under /etc. Find /home name star.log finds all log files under /home. Find /var/logtime -1 finds files modified in the last day. Find is powerful but can be slow on large trees. Always scope it to a specific directory rather than searching from /df and do are how you monitor disk space. DFH shows disk usage for each mounted file system in human-readable form. You'll see columns for total size, used, available, and percentage used. If your root partition hits 100%, your server will start failing in mysterious ways. Log writes fail, processes can't create temp files. Do sh/var/log/* shows how much space each subdirectory of /var/log is consuming. This is the diagnostic command when df shows your disk is full and you need to find what's eating the space. A production habit worth building: set up a disk space alert at 80% usage. At 90%, things start getting difficult. At 100%, your server may effectively stop working. The find and do commands help you identify which logs, databases, or application files are growing unexpectedly so you can address them before they cause an outage. Let's lock in the file system hierarchy with a concrete question. Your Node.js application writes logs to a file. The application crashes and you need to find out what happened. Which directory should you look in first? Option A says /usr/bin. That's where executable programs live, not logs. Option B says /etc. That's configuration files, also not logs. Option C says /var/log. Correct. The /var directory holds data that changes at runtime, and /var/log is the designated home for all log files on a Linux system. Nginx, syslog, auth logs, application logs, they all go here by convention. Option D says /tmp. Temporary files that get cleared on reboot, not the right place for persistent logs. The answer is C /var/log. The file system hierarchy isn't arbitrary. Each directory has a clear purpose rooted in decades of Unix design /etc for static configuration, /var for runtime data, /home for user files, /proc for kernel state, /usr for programs, /tmp for throwaway files. Once you know the map, you know where to look for anything. Next up, Linux permissions, the chmod and chown system that controls who can read, write, and execute every file on your server.